Now let's specifically talk about intracranial interfaces. Next slide, please. I worked with this kind of interfaces for nearly 20 years, and I did a lot of experiments in monkeys. In these experiments, monkeys are implanted with intracortical arrays, and they record activity of many neurons simultaneously. Then the monkey is playing a video game. We record neural activity, train a decoder to convert the monkey's thoughts into actions, and at some point the monkey can stop moving the joystick, and then it would control this video game by itself, directly by its brain activity. Next slide, please. This is, by the way, the monkey brain. The front of the brain on the right, the back of the brain is on the left, and then you can see that there are many areas here that represents parts of the body, eyes, and then there is also prefrontal cortex that monkeys use for thinking. Prefrontal cortex is much larger in humans, of course. So there are many places where one could put an electrode and record neuronal activity. And the pioneer of this research was Edward Everts, who in the late 60s, early 70s, inserted an electrode in the monkey brain. The monkey was awake, and it was performing some actions like pull or push a lever. And then the Everts would record from a single monkey neuron. The monkey didn't experience any pain or anything because there are no sensory receptors in the brain. So here's an example. Next slide, please. So here is an example from Everts' experiment. Here, a monkey is rotating its wrist, and you can see that depending on the angle of rotation, the activity of this neuron changes. So basically, this neuron tracks the position of the wrist. And we can decode position of the wrist from this neuron's activity.